Hello everyone, welcome back to my channel. This is a second lesson on exponents. So today we are doing division of numbers with the same base under exponents. And then there's a note there, they are telling you that when dividing the terms with the same base, we keep the base the same and subtract the exponent. So when dividing the terms with the same base, we keep the base and subtract the exponent. So let's do example 1. As you guys can see, you are having base y exponent 8 divided by y exponent 5. So our bases are the same. We are dividing, therefore we can subtract the exponent as the law indicates. So you rewrite your expression, which is y exponent 8 all over y exponent 5 equals to, so you keep the same base of y, and then the exponent that is on your numerator remain as is. It is positive 8, but the one that is at your denominator will change the sign and be negative 5. So 8 minus 5 is exponent 3. Okay, so let's move to example 2. For example 2, you are given the following. They are saying simplify the expression 25a exponent 5 divided by 5a exponent 2. If you guys can check, you are having the coefficient of 25 for a exponent 5, and then for a exponent 2, you are having the coefficient of 5. As I explained, it is essential for you to first deal with your coefficient. So you can just have 25 over 5 like this on the side, and then we can see we are having a division line. We are having the same basis, which is a, therefore we can subtract the exponent. So we keep the base the same, which is our a, and then the exponent that is on our numerator will remain positive. The sign does not change, but the one that is at our denominator will be negative. So now it is 5 minus 2. So we are dealing with our coefficient. 25 divided by 5 is equals to 5. We are done solving our coefficient. So we bring down our base a, and then 5 minus 2 is exponent 3. Our final answer in this case is a cubed. 5a cubed with the coefficient of 5. So let's do example 3. For example 3, you are having 14y exponent 6 over 2y exponent 3. So again, you can just write your coefficient nicely on the side. First deal with those. It's 14 over 2, and then your bases are the same. You are dividing, therefore you keep the base the same, and then you subtract your exponent. Bring down y as it is, and then your exponent 6 on your numerator remain as is, but exponent 3 on your denominator will change to negative 3 equals to 14 divided by 2 is 7. You bring down your base y as is, and then 6 minus 3 is 3. This is our final answer. Okay, so our next example is example 4. We are given 15k exponent 6 m to the exponent 10 over 3k exponent 4, and then m exponent 2. So we still have to simplify this one. Again, you are having the coefficient of 15 here, and then here you are having the coefficient of 3. First deal with your coefficients, so you can write them on the side. You are having 15 over 3. You are dividing, you are having base k on your numerator, you're also having base k on your denominator. And then base m on your numerator, and then base m on your denominator. Remember, you want to have the same base. So we'll just write our base k as is, and then exponent 6 is on our numerator, will remain as it is, but exponent 4 will change to negative 4. You need to be very careful. I'm subtracting the exponent of base k because currently I'm dealing with variable k. Now we are moving to variable m. You bring down the base m, and then your exponent is exponent 10, and then the one on your denominator now will change to 10 minus 2 equals to 15 divided by 3 is 5. You bring down your base k, and then 6 minus 4, you will get exponent 2. Bring down m as it is, and then 10 minus 2, you will get exponent 8. This is your final answer. And then our last example will be this one. You are having p exponent 10, and then r to the power exponent positive invisible 1 over p exponent 3 multiplied by r. So if you do not have a number here, you know for a fact that this is the invisible 1. You are having base p on your numerator, base p on your denominator. You are dividing as we are having the division line. So what we do is we can start with our base p. So I'm having p exponent 10. Now it will be minus 3. I'm done with base p. I'm moving to base r. Since there's no number, I know it is positive invisible 1. And then the 1 on my denominator will change to minus 1 equals to p, and then 10 minus 3 is 7. And then r1 minus 1 is to the power of 0. So anything to the power of 0 is equal to 1. So we can simplify this expression further because we will have p exponent 7 multiplied by 1. Remember, if there is no sign in between our variables, we know that it is multiplication. So now this r exponent 0 will change to 1, as we mentioned that any number to the power of 0 is equals to 1. Okay, so 1 multiplied by p to the power of 7, it is just p exponent 7. This is our final answer.